I'm going to look at the COICOP classification work done at CBS. This is work done by Chris Lam, Bart Schouten and myself, Tim de Jong. If we look at COICOP classification, we are trying to classify the scanned receipt text into COICOP labels. We can do this either by using a machine learning classifier, by doing string matching, or by a human manually labeling the data. For now, we are focusing on a machine learning classifier. To train a machine learning classifier, we need labeled data. We can either use the labeled receipts, or we can use the receipt text database that we can receive from the stores. This is often available through the CPI data. Questions that arise then are which and how much data do we need? How often do we need to retrain the model? And can we train a model that generalizes well? How much data is influenced by the product inventory and the product dynamics. Which data we can choose between the scanned receipts, which only have a limited sample of products, or the CPI data. This is all data for a store and contains thousands of products. However, the CPI data also have their challenges. Only a limited number of supermarkets provide the receipt text for their database. And the CPI data are only delivered per week or per month, and the time lag may be a challenge for real-time matching and classification. The product dynamics are the number of products introduced and or removed per month. It can be very high, up to 10,000 or 20,000 products per month. The number of products introduced, of course, influence directly the machine learning performance. If we look at product inventory, there's a very low overlap in receipt text. There's also a low overlap if we separate the words in the receipt text. The maximum overlap then is 10%. A large number of products also have short product lifetimes, so they are introduced and then disappear quickly after. Then the challenges and further work. Can we train a machine learning model that generalizes across stores? The challenges here are lack of data. We don't have the data of a lot of stores. The differences between stores and the high product dynamics. We are looking at collecting more supermarket data at the moment, and we want to analyze it further. We want to look at inventory overlap with other supermarkets. We want to look at product dynamics, and we want to see if we can identify specific patterns in the receipt text, either for cleaning or for increasing the performance of the machine learning classifier. And last, we want to train a machine learning classifier. Then we are looking at the performance per supermarket. We want to analyze the machine learning performance over time. How can we make it generalize better? Maybe we can find any tricks. And maybe we can use a combination of string matching and machine learning classification. In this case, we first use string matching to do the labeling, and then we can use a machine learning classifier for the products that cannot be classified correctly by the string matching.
Hi, this is Jerome from Destatis. Now that Tim has nicely elaborated the current ideas and steps involved in developing the classification algorithm, we want to give you a short demo of the current state of the microservice implementation. This will demonstrate that we're already able to load a simple classification model within a Docker container, receive new input data which is not yet classified to COICOP, and then make predictions on this. So what you're seeing here is Peter Bain's screen, and basically this is the step of building the container-based Docker file, which then starts R. And those who are familiar with R will now recognize something familiar here. And what then happens is that this microservice is able to receive new input data. Here you see 6 rows of example data that we're loading, so different types of writing yogurt, eggs, Coca-Cola, milk. And these terms are then pre-processed, meaning that stop words and certain characters are being deleted. Look, for instance, that Coca-Cola is now a single word. And after that, the actual prediction model is being loaded. When this is being loaded to memory now, it takes some time. Later on in production, this will be held in memory. Therefore, later you won't have these delays and you will have much quicker classification results. Now that it is loaded, again, the data runs through a certain routine so that the prediction input looks the same as the training data input. And then it is actually sent to the model so that a prediction can be made. And after this prediction has run, the results again have to be post-processed so that per row the highest probability COICOP prediction is extracted and also the probability value that goes with this prediction. So now in the next step here you will see that 2 columns are added. The first one being the 7-digit COICOP code in our case of this example model and the probability value. Look for instance at the 2 different probability values for different types of writing yogurt, which for the German language the second one would be correct, where you have a probability of 100%. So later on in production, this entire process will be fully automated. We hope you like this simplified impression of the current state of the microservice. Thank you very much.
In this video, I'd like to illustrate one way to couple a COICOP code to a purchase. We are making use of a list of search tags and a search engine that can then be used to present a list of COICOP categories. A good list of COICOP codes and commonly used search terms is vital for a good performance. We at the Status worked on a list of over 100,000 search tags for the 575 COICOP categories in total we wanted to include in our research. To illustrate the search engine, I picked out rye bread as an example for a COICOP category that we want to search now. Once the list is uploaded, we can make use of the MileySearch microservice. In this case, I'm going to illustrate the MileySearch engine in the back office first, as this is the place where you will set up and configure the list to your liking. You can choose different lists, and in those lists you can create subcategories, periods with more or less selectable search results, and so on. All those details determine how the search algorithm acts in our specific research. Typing in rye bread results in a total of 5 search terms popping up and giving out COICOP categories. As you can see, rye is placed in the search tag list for a couple of COICOP categories. In the front office, in this case the mobile app, we can do a similar search. With a new expense and the same search term, the search works accordingly. The same results are being shown with the addition of a search term that is currently not selectable, as it's a broader category and we want more detail for now. Additionally, an other category is being shown, since you might have an expense that we could not yet integrate in our own list. Saving the search term also saves the expense in our app. It can now be found also in the back office and is stored as a COICOP category paired with a search term that has been used.